Welcome to a new episode of Upcycled Industry. Today we have with us Tato Bigio. Welcome, Tato.
Hi, how are you?
I'm good, thanks. So Tato is the co-founder and CEO of UBQ Materials, which is an Israeli clean tech company that converts household waste into a novel thermoplastic material. So I'm really curious to know more about UBQ and your story, your background. So I will give you the floor and let you introduce yourself and what's special about UBQ.
Thank you. Thank you very much, Nathalie. I am co-founder and co-CEO of UBQ Materials. We established this company in July 2012 with a very preliminary idea to take the entirety of the household waste without the need of separation and convert it into a usable material. We knew the base of the chemistry, but the development, of course, was as challenging as it could be. The difference between UBQ and any other material technology around thermoplastics is that as opposed to other companies that they need the separated waste streams in order to recycle them. So if you're talking about plastics, you have to separate each one of the plastics and then convert them into the recycle or the chemical recycling as much as paper and cardboard. And of course, you need to clean them and wash them and use tremendous amounts of water. UBQ is using 100% of the waste. And when I say 100%, I mean also the organics, especially the organics. There is no other technology that is taking the food residues in our plastic bags and incorporating them, or basically using them as the base chemistry for a process conversion. That is the uniqueness of UBQ material. If you consider that the waste is 85% cardboard, paper, and food residues and garden trimmings, and only 15% is mixed plastics, then UBQ is attacking 100% of the problem by converting all these materials before they go to landfill, right, into a usable thermoplastic that actually can replace oil-based resins like polypropylene, polyethylene, polyester, PVC, right? The only difference is that our material is made out of garbage and not out of oil. That is UBQ. My personal background is in project development, financing, and managing or incorporating companies. And with that experience, basically we put together a tremendously impressive team of people. Advisors, academicians, engineers, to create and develop this technology to the place we're today.
Nice. Seems very interesting. And thank you also for mentioning the sustainability aspect. Could you maybe elaborate on that a little bit more? So you were talking about the waste problem that we are facing now. Can you maybe tell me something more about how do you think that UBQ could contribute to solve this huge problem that we have now?
Very good. Yes. Look, humanity is producing every year 2 billion tons of household waste. That's equivalent to the weight of humanity multiplied by 5 times. It is also equivalent to 10 million jumbo jets. 10 million jumbo jets full of people. That's the weight of the waste that we produce every year, and it's only growing because population is growing and economic condition is growing. So regrettably, we have a huge problem. We're not only depleting natural resources in this circular economy where we extract and then end up throwing things in landfills. Some of them we use for a few minutes only or a few seconds. But the problem is even bigger because landfills, they are one of the biggest pollutants of methane. Now, if you consider that methane today is recognized as probably the most significant greenhouse emission gas that exists in the planet and that we need to attack, and that is part of the resolutions in Glasgow with the last COP26, then landfills are one of the major polluters of the planet because organic material decomposes into methane. when it's landfill, when it's decomposing anaerobically, okay? So fact is that by using all these materials before they're landfilled, we're saving enormous amounts of methane. That is number one, right? So we are, in a way, we're saving carbon emissions in a very big form. Methane is 86 times more impactful than CO2. So saving a few hundred grams of methane emissions is tens of kilos of CO2 equivalent, right? That is what UBQ is doing, and bringing to the market a climate positive or carbon negative material. Number two, we're using natural resources that are disposed to create a new material. Number three, we are replacing oil-based resins. And number four, we are contributing to a very manageable circular economy because, as I told you before, we will take the waste as it is, going to landfill, okay? And we will eventually be able to recycle this material time and time again, therefore supporting a truly circular economy, which is the dream of all of us. So we are one technology that is helping the planet in its future challenges, to leave something better for our kids.
Interesting. So let's maybe go back to the technology, the technical aspect a little bit more. So you mentioned that it's mainly the organic fraction of waste that it's converted. So could you maybe tell me what kind of not raw material, but what components or molecules are actually converted into a new plastic-like material?
Perfect. As I told you before, the standard composition of household waste in big cities, okay, where the collection is taken from houses and then brought into a transfer station. From there, you can either incinerate, which is not a very common way of disposing of waste. Maybe yes in Europe, but not in the rest of the world. Most of the waste will end up in landfill. Some of the waste will be taken for recycling, but then again, you have a lot of residual because there is a lot of dirt in the cardboard, in the paper, in the plastics, in the meats that you cannot recycle. So what UBQ is taking is what is going to the landfill, and the statistic is very strong. Basically, it's anywhere between 80 to 85% will be organics, and when I say organics is, again, food residues, cardboard, and paper. Remember, these are cellulosic materials. They're made from trees. So what UBQ is doing is we are breaking through our process, our conversion process, which is patented, of course. We're breaking apart that organic material into its basic natural components. There's a lot of ligaments and fibers and sugars that are present at the particle level, that when you break all these materials into these components, then you all of a sudden have a common denominator of ingredients to convert again into something different. So you forget you have a banana peel or a chicken bone, okay, or a piece of paper once you break them apart into these basic natural components. And what we do is then we blend them together. We create a matrix, okay, building block with all these elements, and that is the base of UBQ material. Now, the plastics that are part of the waste, and as I told you before, we don't separate the waste in different streams. We use everything together. They will melt and bond into this matrix. It has a very strong polar and negative surface tension. So all these plastics will blend and will be bonded into this matrix and will become part of the material. So UBQ is a composite material, okay, that brings together all these different streams in one consistent, homogeneous, and usable thermoplastic that can be used in current industries, plastic industries, to make end products.
Nice. So maybe before to start talking about the potential applications of the material, so you were talking about the conversion process, and I was wondering how is the efficiency of this conversion actually. So with imagine that we have 1 ton of waste, how much of UBQ material can you get from it?
So we we have a 100% conversion rate. In other words, if 1 ton of waste will enter the reactor, okay, you will typically get about 0.7 to 0.75% of UBQ material at the end because of the evaporation of the water. So the only loss we have is water, which is evaporated in the process. We don't have any leftovers, any wasted materials, any sludges. The only thing we take out of the waste stream before we go into the reactor is metals and minerals because they're dense and they are abrasive and they don't contribute to the chemistry.
Luckily, not organic.
Also are highly recyclable and they command good prices, specifically metals. So it's 100% basically a conversion. Where after taking the glass and the minerals and the metals, all these materials combined out in the reactor. The temperature is highly efficient. We don't work with temperatures about 220 degrees centigrade, which is quite low. It's practically the same as the plastics industry. We don't use any water. As I tell you before, we have enough humidity in the waste, so we don't need to use any water as opposed to all the other technologies. And the process is being developed in a very automated way. So in terms of human resources, basically we need an operator for each reactor, and the process is, as I tell you, clean, waterless, wasteless, and energy efficient.
Thank you for the explanation. And concerning the applications, the potential applications, so what items, what objects could you actually manufacture using your material? So we are talking about for objects for which kind of industry?
Right. So let me explain. We convert the waste into UBQ material and then ship it to our customers, which are the plastic manufacturers, in the form of pellets. Like this, for example. Okay, this is UBQ with a red additive. There you have one with a blue additive. Okay, this is what we ship. We don't make products. Okay, our clients will make the products. What products will they make? So, for example, one of our big clients today is McDonald's. They are doing, amongst other, food trays like this. Here you can see the logo of UBQ next to them. I mean, they stamp the logo of UBQ in the tray to show that this is sustainable, bio-based, climate positive end product. We're working with Mercedes-Benz, which is, I would say, it's one of the most demanding industries. The car industry has very high standards, and we're working with Mercedes-Benz. Actually, we're working at the top of the pyramid, and yet again, we have 15 different car parts being done with UBQ material. We have collaborations with Manetti, for example, which is the biggest fashion packaging company. They're doing plastic hangers. They're the biggest in the world. So you can inject this material and form it through injection molding processes. You can extrude this material, so you can do pipes, panels, roofing, sidings, this type of long elements or products. You can compress mold and make anything that is compressed. And you can also blow mold it. So you can do, for example, the kind of bottles that are blow molded. And lastly, we develop a 3D printing application. So basically, UBQ can be also fed into 3D printers to create products. Any product made with UBQ can be either carbon neutral or carbon negative, meaning climate positive. And therefore, any product that is using today UBQ material, like this tray or the pipes or the car parts of Mercedes or the hangers of Manetti, they are the first plastic products in the planet that are climate positive. And that is a very strong value proposition that we bring to our customers, in addition to the fact that we're using waste, that we are supporting a circular economy, that we're replacing oil-based resins, and we have a highly recyclable material. So this is why we're getting a lot of interest. Our material is competitive. Some of the technologies in the realm of bio-based materials are more expensive and therefore difficult to implement. In the case of UBQ, we're competitive with common-based resins, so the adoption is easier, let's say.
So you are already mentioning all these properties, but generally compared to traditional oil-based plastic materials, so what other properties characterize the UBQ materials, also in terms of performance, durability?
The material is highly resistant. It complies with industry standards. As I told you, in order to penetrate these high-end industries, we have to go through a tremendous amount of certification, validations, with the top tier labs in the world, and show that we comply with the health and safety regulations, performance regulation, mechanical properties, etc. The important thing is that you have to remember is that the plastics industry, the manufacturing industry, has been used to source resins, oil-based resins, for the last 100 of years. When you come with a new material and you want to integrate it in an existing product line that has been built for a specific thermoplastic, polypropylene, or polyethylene, or polyethylene, and you cannot mix between them because you know that plastics, they don't like each other, okay? In the case of UBQ, you can use UBQ and integrate it inside a polypropylene product, or integrated with PVC, or with P, or with a PS, polyester, which is quite remarkable because these plastics don't talk with each other. But UBQ talks with all of them. So basically, we can be integrated. And what typically the manufacturers will do is, taking into account that all these molds and all these processes and all these machines has been designed for a certain product application, they will start adding UBQ to the level where the mechanical properties or the, let's say, the visual properties or any other properties that they are looking reach a point where UBQ might start shifting the properties of the material. So it can be used at rates of anywhere between 10% to 80%, depending on the end product. But if you design a mold, okay, for UBQ, which is something that will happen eventually in the future because we will become a standard in the industry, you can do products made with 100% UBQ. But remember that we cannot change the industry at this stage, and we don't intend to change the industry. We just want to penetrate and give an alternative for manufacturers to use more UBQ material, to have more, let's say, climate impactful end products, to comply with their, commitments of dropping their carbon emissions, being greener, being more sustainable, being more circular. And that is what UBQ is really doing. Eventually, also our material is developing. So the use of UBQ material expands in different industries, in different sectors, in different applications, and the percentages of UBQ material being implemented are going high and high. It's an industry that is developing. UBQ only went left, we presented the material to the market only 2.5 years ago. Mm-hmm. So all this has happened in the market just in the last 2.5 years. And as we speak, our research and development department work tirelessly to create new generations of UBQ material to have better compliance, better applications. But today, we're definitely, working with, as I told you before, in all these industries, supplying. We have a problem of course of supply. We don't have enough material at this stage. And we're building now a plant in the Netherlands that is big enough to supply our current demand. But as we move forward, we know that the demand is only growing, and definitely we'll have to establish many more plants, not only in Europe, but also in the United States, Latin America, Asia, Japan, Australia. I mean, there is plenty of waste everywhere, and the use of plastics is not only huge, but it's only growing. So we have plenty of space to continue developing this material and this company.
Mm-hmm. Yeah, absolutely. Especially considering that the population is increasing, I can imagine that waste is just something that we should start thinking as a resource instead of just something that we have to burn and get rid of it, and it's very polluting as well. So thank you for mentioning it.
Nathalie, I just want to say something. I just want to say something. What you just said, I think what you just said is very, very important. The fact that we call the waste is already a problem. Waste is not waste. Waste is waste as long as we waste it. So waste is a natural resource, and the name waste is dropping a lot of the value of what we have there, and there is tremendous value in waste. And UBQ is one of the technologies that learn how to unlock that value. So waste is not waste. Waste is a natural resource.
Yeah, really interesting. I totally agree. And maybe because you say that, for example, UBQ materials could be used, for example, for food trays. So also products that are directly in contact with food. So my question is generally, what is the public perception or acceptance of this kind of material? So do you see any skepticism, or people are just happy that there is a new potential resource that can replace plastic?
First of all, regarding food, we're not working today with direct contact. This tray is what you call a near food contact, because you are not packaging here food or fresh food. For that, you need to go through a very long process, and it's something we will eventually do. But we have so much demand in all these other applications, transportation and logistics, boxes, pallets, bins, waste bins, car industry, construction, everything I was telling you before, 3D printing. So, step by step, we're going to be penetrating also the food contact industry. But as I told you before, we have so much to demand to supply in all the other sectors that, we're focusing on that. Regarding the acceptance, it took a while to convince that, the industry that this is a material that is safe to use, that it performs well, that it has all the characteristics that they were looking for, notwithstanding that it is made out of waste. But this is not waste anymore. This is basically a new composition of matter. By the way, that is the reason why we could patent it. It's a new composition this is a new material, and it's not waste anymore. It's UBQ composite, and UBQ is completely safe to use. So once we reach a point where all these certifications, validations, and testings were done, and all these industries starting adopting UBQ, the adoption is going faster. That's number one. So once people know that McDonald's and Daimler and Manetti and Mercedes, all these companies are using UBQ, it's easier. Number two, manufacturing industries, brands are more exposed to the pressure of customers and consumers to do something. So even in the past, they will see it, patiently and say, okay, you know what, I don't have time for this. Well, today they have completely switched their mindset, and they have understood that they need to change. So when you change, you need to dare, and you need to take decisions. Sometimes riskier, sometimes they turn to be more advantageous, but you have to do something. So the environment today, is such that everyone is willing to test UBQ material, and today with all these certifications, as I told you, and all these clients, we're not encountering any more skepticism on the material. On the contrary, we're just getting more and more interest.
Mm-hmm. Thank you. So before you said that UBQ has the goal to become the standard, so also to scale up and to be available in different countries. So do you think that actually the technology could be applicable to different countries, or there are any barriers, maybe in terms of regulatory issues, or do you see UBQ be everywhere?
Yeah, I first of all, I tell you the amount of plastics that is being consumed in the world is so humongous. It's so huge that that UBQ, for UBQ to become a very significant player in that market, say to have 10% of that market, would mean that we would need to do hundreds of factories of UBQ, hundreds of factories. It's just that the plastic market is so overwhelmingly huge. You're talking about 400 million tons of plastics being produced every year, and it's growing. Okay, so definitely we can be the standard in the bio-based, climate positive, sustainable, circular materials. The challenge of UBQ is to expand as fast as possible to bring this extraordinary solution to every corner of the planet. Waste is available everywhere, household waste. I mean, where there is people, there is waste, right? And household waste is one of the natural resources more available anywhere where you have people. So in that sense, we have plenty of raw material, right? Regrettably, I say, because it's too much. I mean, we're producing too much waste. And in terms of regulatory, we don't have issues basically because it's a certified technology, it's a certified process. I told you we don't have any emissions. We're working with relatively low temperatures. We're not using any water. So as much as we have a business permit here in Israel in our factory with all the licenses and of course all the regulations, same is happening to us in Europe. So we're already at the highest standards. So we don't foresee issues to replicate this technology basically in every corner of the planet, except the fact that, please remember, I mean, you need to deploy capital, you need to deploy personnel, you need to build factories. So this is a challenge, right? I mean, it's not from one day to the other. But of course, the plan is just to grow as massively as possible and to be more relevant. The more UBQ we produce, the more landfill waste is avoided, the more methane emissions are avoided. So just by using UBQ, you're doing something good for the planet, and we would want consumers to reach more UBQ material in many more applications. For that, we need more expansion, more factories. As I told you before, we have a big challenge ahead of us, but it's a beautiful challenge. It's a positive thing, and we're very excited about the prospect of this material.
Thank you. So maybe to conclude our interview, could you give our audience some last comments, generally, or if you want maybe to talk about, you were talking about challenges in general, could you maybe tell something about some of the challenges that you were facing with UBQ and you overcame that?
Of course. First of all, on the challenges, I have to say that I would always tell anyone who is developing a technology or a company that is doing something different is just you have to be very very thorough in your process. You have to do things right. You cannot overcome problems just by avoiding them. You have to overcome the problems, and then before you go out, you should definitely be aware that any mistake you will be paying too much for it. I mean, you should avoid making mistakes, meaning that you have to validate, certify, test as much as you can before you expose your material to the market, because you want the market to embrace it. And once you start having problems, that is the place where no other opportunity will be given to you, and all the work will go down the drain. So spend a little more time making sure that everything is set, that the material is set, the technology is set, that the process is validated, and everything I told you before is in place, and then you will have better chances. So in terms of what I would expect is basically this trend will continue, meaning that consumers will lead the way, will really put the pressure for industries to make changes in line with our expectations as human beings, that we want to have a cleaner planet for ourselves and for our kids, and to leave natural resources for generations to come, which is what is called basically a sustainable life. And for that, as much as customers demand these things from their suppliers or the brands, then you see the effect. They are obliged to do things, then the government comes and starts imposing regulations and advantages for these industries, alternative industries, to become the standard. So for that environment to happen, I think that consumers and governments need to lead the way, so that the industries will shift to new ideas, to new propositions, and let all these industries become eventually profitable enough so that they can compete with all the industries, that have already, let's say, conquered the markets, but they also need to make the shift. So I would always say that to consumers, just continue sourcing and demanding greener, sustainable materials in your end products, and as much as you can, save producing waste. That's the first problem. If we just cut a little our consumption and we cut a little our waste, then already we have solved part of the problem. Then comes UBQ and other technologies that whatever is left can be hopefully brought back to the economy and create a new circular system that will support future generations. So, but the trend is there. So luckily, we're in a good place, in my opinion. It just should continue.
Thank you. That was very insightful. And I totally agree that consumers are always more looking for more sustainable solutions. And of course, it's the consumer that somehow leads what the industry will produce. So thank you for that. And also for your work. I mean, it's amazing. And I truly believe that generally waste holds an immense potential. It's a question just to understand what properties do they have. And thank you for our conversation.
Thank you, Nathalie. Nice to meet you.